Hi, here we are back looking at exponential form and logarithm form. What we're going to do today, this is just a review here to begin with, and then we're going to work into how we can change forms using natural log instead of just regular logarithm form. But let's review first of all how we actually change from log into exponential form. So first we have 2 equals log base 3 of 9. If we were going to rewrite that in log form, our base is 3, our exponent is 2, equals 9. On the second one, x equals log base 3 of 4. Base is, again, 3 to the x power equals 4. On that last one, on letter C, if there is no base, there's a base of 10. So we would have 10 to the x equals 14. And then going the other way, we can do the same basic idea. If it's given as an exponent and you need to write it in log form, 4 to the x equals 8, we'd have log. Our base is 4 of 8 equals x. On letter B, we would have log base 5 of 4.5 equals x, and log base 9 of 10 equals x. You can change forms with natural log and e in a similar fashion. So just to remember that log, the base of e, is equivalent to the natural log. Okay, so if we have e to the x equals 1.5, zoom in here, that means essentially we're having a log base e of 1.5 equals x. Okay, well, down below, just a second ago, I said log base e is equivalent to natural log. So if we have log base e of 1.5, we don't want to write it with a log base e, we want to use natural log. So we'd use the natural log of 1.5 equals x. And if we put that into our calculator, it's approximately 0.405. Okay, and we can do, and again, we do not necessarily need to show this step right here. That's just explaining where the natural log actually comes from. So if we had e to the x equals 12, that's saying log base e of 12 equals x, but we're going to call that natural log of 12 equals x. And natural log of 12 is approximately 2.485. Okay, and just moving on, looking at a couple more examples here. E to the 5x equals 12 means we'd have the natural log of 12 equals 5x. Well, we don't want 5x, we want we want x, so I divide both sides by 5. When you put this into your calculator, you need to make sure you close those parentheses after the 12 so that it does the natural log of 12, gets that number, and then divides it by 5. And if you do it correctly, it should be approximately 0.497. If we have e to the 10r equals 1.8125, that would be the natural log of 1.8125 equals 10r. Again, we don't want 10r, we want r. So if we divide both sides by 10, again, making sure we enclose that 1.8125 in the parentheses before we divide by 10, we should get approximately 0.059. Going the opposite direction, if we have the natural log of x equals 5.65, essentially what that means is log base e of x equals 5.65. Okay, so when we're going from natural log into exponent form, our base is always going to be e, so we'd have e to the 5.65 equals x. Again, this step right here where we change it into a log base e, we don't need to show, we just need to know that if we have a natural log, our base is always going to be e. So on the second one, the natural log of x equals 7.2 would be e to the 7.2 equals x. The next one, we actually have a coefficient out in front that we need to take care of first. We have 3.5 times the natural log of x equals 7. Well, we don't want 3.5 times the natural log. We need to get the natural log by itself first. So we should divide both sides by 3.5. And 7 divided by 3.5 is 2. So if we're going to change that into exponent form, it would be e to the second power equals x. Same idea here on 5 times the natural log of x equals 45. First, we would want to divide out that 5, and we'd get the natural log of x equals 9. If we change it into exponent form, that would be e to the 9th equals x. One way that we can actually use this is on the problems that we were doing the other day, where we had interest compounded continuously. And when we left off with one of those questions the other day, we didn't know how to find the interest rate if they made certain amount of money over so many years. Now we're going to be able to do that. So if you invest $4,000 for 10 years, and then at the end of that 10 years you have $7,250, we want to know what the interest rate was. So if we look at our formula, A equals P times E to the RT, the amount we ended up with was $7,250. The principal, P, that we originally put in was $4,000. E to the R, we don't know what the rate is, but the time is 10, so we'd have 10R. Again, the first thing we want to do is to get rid of that 4,000 that is the coefficient. So we're going to divide both sides by 4,000. And we get 1.8125 equals e to the 10r. Well, anytime that we have a variable in the exponent here, like 10r is part of our exponent, that r is the variable that we're trying to solve for, we need to change it from log or natural log, or excuse me, from exponent form into natural log form so that we can solve for r. In order to do that, we're basically thinking, all right, so we'd have like the log base e of 1.8125 equals 10r. Again, but we know that if it's a log base e, that's the natural log of 1.8125 equals 10r. And we don't want 10r, we want 10, so we're going to make sure that we enclose that 1.8125 into the parentheses. In our calculator, we're going to hit natural log of 1.8125, close the parentheses, divided by 10, and we should get that r equals 0.059. Well, if we are going to write that as a interest rate, 0.059 means that this person had a 5.9% interest rate on their account. Okay, this problem is very similar to the last one. We have, this time we invested $5,250 for 6 years, compounded continuously, and we ended up with $8,520, and we want to know what our interest rate was. So the amount that we ended up with was $8,520. Our initial investment was $5,250, e to the r times t, so we'd have 6r. Again, we don't want to have that coefficient, so we're going to divide out the 5,250 on both sides. And we end up at 1.623 equals e to the 6r. If we have that variable is in the exponent, we need to use natural log to get the variable out of the exponent. So we can take the natural log of 1.623 equals 6r. And again, we don't want 6r, we want r. So we divide both sides by 6. Again, in our calculators, making sure we close that 1.623 in parentheses, and we get that our rate is roughly 0.081 or 8.1%.